Hey guys, welcome back to another RASK Maths tutorial, and in this tutorial I'm going to be showing you guys how we can actually derive the formula for integration by parts. So integration by parts is actually a really useful tool when we have integrals such as x e to the x dx, where it's pretty obvious to differentiate one function within the composite function, and it's also easy to integrate another part, but it's hard to sort of do them together. So it allows us to separate the easily differentiable function from the easily integratable function. And yeah, I'm just going to be showing you guys how to derive that. It's actually pretty simple. So what it really comes from is the product rule. And the product rule states that if you take the derivative, actually let's do some definitions. So let's just say we have two functions u of x. So let's take the derivative of u of x multiplied by v of x, where v and u are just functions of x. So I'm just going to rewrite that as d over dx u times v. And the product rule is basically saying that that's equal to the derivative of u multiplied by v plus u multiplied by the derivative of v. So just taking the derivative of each multiplied by the other. And yeah, this can actually be generalized with Leibniz rule, where if you have d over dx of u times v times w, that's equal to u dash vw plus v dash uw plus w dash uv, like that. Pretty simple. So that's the basic product rule. Let me just write product rule. Okay, so if we start with this, v du plus u dv. Now, let's observe what happens when we integrate both sides of the equation with respect to x. And the reason we can do this is because these are actually functional equations, so they're valid for all values of x. And you should know that if you integrate the derivative of a function, that is simply just equal to the function itself, because of the fundamental theorem of calculus. This is basically what it states. Integral is the inverse of derivative. So using this line now, we can simplify this. Well, this left side, these two cancel out, which just gives us uv. And that's equal to the integral of v du plus the integral of u dv, just like that. And now you can see if we just move this, so rearrange it to get in the form integral u dv is equal to uv minus the integral of v du. So yeah, here's the formula. It's pretty easy. And basically what you do is, so let's say we have an integral such as integral of x e to the x dx, okay? So what we're going to do is, using this formula, we're going to set, well, we can see this formula states that we need to find the derivative of u and the integral of v. So if we set u is equal to x, and we'll set dv equal to e to the x, now it's going to allow us to easily calculate what du is. That's just going to be 1. V is the integral of dv's, which is just e to the x. So plugging these things back into the formula, the right hand side, we're going to get that's equal to uv, like so, is going to be x e to the x minus v du, or du multiplied by v, which is just going to be integral of e to the x dx, because remember, if we differentiate x, we don't just get 1, we actually technically get dx, but we usually just leave it as 1. We'll keep the dx separate, but that's just a small thing. And yeah, then if we integrate this nice and easily, we can just get our final answer, which is x e to the x minus e to the x. And we should probably add the plus c at the end, just to show this is an indefinite integral. And yeah, you can see what I've kind of done here is, this is really similar to the tabular method, if you've ever used that, where you differentiate on the left column and integrate on the right column. And yeah, you can just keep going down until eventually you hit a 0, at which point you won't be able to differentiate any further, and all points after that would be 0. That's basically where this comes from. And yeah, this was a simple derivation of integration by parts. So thanks for watching, and I'll see you guys in future tutorial. Bye.